Hello and welcome to Vodcast 14.1. In our first Vodcast for Chapter 14, I will overview air masses. Put as simply as possible, air masses are huge bodies of air. These things can be more than 1,000 miles across and miles thick. Air masses will have two very important characteristic properties, the first of which is temperature. An air mass will have similar temperature at any given altitude. So as an example, let's take a look at the picture shown on this slide. That really big, huge blue oval you see up in northern Canada is an air mass. And the characteristic temperature for all of the air in that air mass is cold. That probably doesn't surprise you. In northern Canada, up by Alaska, and into the Arctic region, it is very cold. Now the other important characteristic that defines air masses is moisture content. Our huge blue air mass shown in this picture is dry, meaning that it doesn't contain a significant amount of water vapor. Now over time, air masses move and they can affect a very large portion of a continent. The air mass shown on the screen, which originates in northern Canada, will move south and affect almost the entire continent. Notice that when it starts, it has temperatures of negative 51 degrees Fahrenheit, and as it works its way south, the temperatures will increase slightly because it's working its way towards the equator. But those are really cold temperatures for all the cities in the path of this air mass. As examples, Omaha, Nebraska, 9 below zero on the Fahrenheit scale, Oklahoma City, 5 degrees above zero on the Fahrenheit scale, and even down into Houston, this air mass is causing freezing temperatures of 25 degrees Fahrenheit. Air mass weather can affect a region for many days, so this cold, dry air mass could cause very chilly temperatures in the winter months for this entire region shown in blue. Let's talk about specific classifications for air masses. For starters, we need to define source region. A source region is where an air mass acquires its properties. So as an example, for the air mass on our previous slide, it acquired its properties up in northern Canada. So the characteristics for that particular air mass were cold and dry. Now it's very important that you understand how we classify air masses. There are two primary criteria that we'll use when we do so. The first criteria is by latitude of the source region. Put quite simply, if the source region for an air mass is at or near the equator, we will classify that air mass as a tropical air mass. But if an air mass has a source region that's up in the high latitudes, say up in the northern Canada region, we will classify that air mass as either polar or Arctic. Arctic air mass classifications only really matter during the winter months, but polar classifications describe any air mass coming out of a high latitude region. The difference between tropical, polar, and Arctic air masses is the temperature of the air mass. If the air mass is classified as tropical, it will contain warm air. If the air mass is classified as polar, it will contain cold air. And if an air mass is classified as Arctic during the winter months, it contains very cold air. And it's also very important that I state that we will use the capital letter T to symbolize tropical air masses, the capital letter P to symbolize polar air masses, and the capital letter A to symbolize Arctic air masses. The second criteria that helps us classify air masses is the nature of the surface in the source region. Put as simply as possible, does the air mass form over water or does it form over land? There are only two surface classifications that we need to know. The first is continental, which we'll use lowercase c to represent. Continental air masses will form over land, and anytime an air mass forms over land, it will contain dry air. The second surface classification is maritime, which is represented by a lowercase m. Maritime air masses form over water. And as you can probably guess, anytime an air mass originates over water, it will have a high moisture content, and the air will be humid within that air mass. Let's take a look at the picture shown on this slide, because I think it really helps tie everything together, and it also serves as a really good cheat sheet for all the concepts that I've just overviewed. I'd like to start off by focusing on the summer months, which is shown at the far right of the slide. During the summer months, we see a maritime tropical air mass coming off of the Gulf of Mexico and working its way northward into the continental United States. The way we symbolize that maritime tropical air mass is with a lowercase m, capital T, and the air contained in that maritime tropical air mass will be warm and it will be humid. In fact, that maritime tropical air mass serves as the fuel for a lot of the thunderstorms and the severe weather that we experience in the Midwest. The second type of air mass I'd like to overview in this picture is the continental polar air mass you see in northern Canada. The source region for this air mass is in a cool region because it's at a high latitude, and because it forms over land, it will contain primarily dry air. I should also mention that when we write the air mass symbols, we start by describing the nature of the surface, meaning that you'll start with a lowercase c or a lowercase m, and then the second letter represents the latitude of the source origin. So for a continental polar air mass, we start by writing lowercase c and then capital P. Now to each side of the continental polar air mass, you see maritime polar air masses. These air masses will also contain cold air, but the difference is they form over the oceans, so they will contain humid air. And then the last air mass shown in this image is a very small air mass that originates in Mexico, and that's the continental tropical air mass. It's a continental air mass, so it will contain dry air, but it's tropical because it's at a relatively low latitude. So your continental tropical air mass will contain hot, dry air. On this slide, I'd just like to briefly touch on how some of these air masses affect North American weather. I'd like to start by focusing on the continental polar air mass. Now during the winter months, the continental polar air masses can bring us very cold, very dry air that really cause temperature plunges. But during the summer months, these continental polar air masses can bring us some heat relief and help us break some of those really intense hot spells that we experience. The maritime tropical air mass might be the most important weather-producing air mass that we talk about in this chapter. I'm going to focus on the maritime tropical air mass that originates in the Gulf of Mexico and the Atlantic Ocean. These air masses bring warm, moist, and unstable air to our continent. And when that warm, moist, unstable air in the maritime tropical air mass runs head-on into a continental polar air mass, you can see some really strong frontal wedging and then some very intense storm production. In fact, the maritime tropical air mass that comes off the Gulf of Mexico can interact with continental polar air masses to form tornadic conditions, especially in our spring months. The third air mass that affects North American weather is the maritime polar air mass. The maritime polar air mass, which contains cool, humid air, will bring ample precipitation to the western mountains, but I'd also like to highlight the maritime polar air mass that forms on the east side of Canada. During the winter months, this air mass can produce what our friends in New England call nor'easters, and nor'easters can bring blizzard-like conditions and huge amounts of snowfall to New England. The last air mass I'd like to discuss is the air mass that has the least amount of impact on North American weather, and that's the continental tropical air mass. The continental tropical air mass can affect the southwest and Mexico, and it contains hot, dry air, but if you look at its position in the summer image, you can see that its influence is pretty limited in comparison to the other air masses that affect North American weather. The last thing I'm going to talk about in this video podcast is lake effect snow. Continental polar air masses are ultimately responsible for lake effect snowfall. And what basically happens is these continental polar air masses, which originate in Canada and contain cold, dry air, move their way south and eventually they'll cross the Great Lakes. Now it's very important to note that during the winter months the land will be very cold, but the Great Lakes will be relatively warm compared to the surrounding land. So when that continental polar air mass crosses the Great Lakes, it'll suck up a pretty good amount of heat and moisture off the surface of the Great Lakes. And as a result, there will be good snowfall on the leeward shores of the Great Lakes. If we take a look at the average annual snowfall map, you can see that the leeward shores of the Great Lakes get hit with a huge amount of snowfall. In fact, if you look at the New York region by Buffalo and Rochester, they are both among the snowiest cities in the United States. So in summary, if continental polar air moves over a relatively warm lake during the winter months, that cold, dry air mass will acquire both heat and moisture, and in doing so, it will dump huge amounts of lake effect snow on the leeward side of the lake. Okay, that concludes this video podcast. I hope you have a pretty good understanding of air masses and how we classify them. In our next video, I will introduce warm fronts and cold fronts.